We are given that in a regular polygon, exterior angle is 1 more than the number of diagonals, and we have to determine the sides of the polygon as well as the measure of each interior angle. So let's see how to determine the sides as well as the measure of each interior angle. For this, we are going to utilize the formula as well as one of the property of exterior angles. The formula says the number of diagonals of n-sided polygon equals n times of n minus 3 over 2. And also we use the property that is sum of exterior angles of a regular polygon equals 360. And this means the measure of each exterior angle of n-sided polygon, and this equals, you just have to divide this 360 over n. So this expression gives the measure of each exterior angle of a regular polygon. Now let's convert this statement into mathematical equivalent. So here it is given exterior angle. So I'm going to write down the expression for exterior angle, that is 360 over n, and this is given as 1 more than the number of diagonals. So I put 1 plus the number of diagonals. I put this expression, that is n times of n minus 3 over 2. Now we have to solve this equation for n. So first let's simplify the right side. So I'm going to multiply this 1 by 2 and divide by 2, and then we have n times of n minus 3 over 2. So 1 times of 2 is 2, and plus n times of n minus 3, we can distribute this n with terms inside the bracket. So therefore this becomes n squared minus 3n over 2. And this side we have 360 over n. We can do the cross multiplication as like this. That is 360 will get multiplied with 2, and this n will get multiplied with the expression in the right side. That is, I can rewrite this as n squared minus 3n plus 2. Now let's simplify this. 360 times 2 is 720, and this equals n times of n squared is n cube, and n times of negative 3n is negative 3n squared, plus n times of 2 is 2n. We can bring everything to one side and rewrite as like an equation, that is n cube minus 3n squared plus 2n. We subtract 720 from both sides, minus 720. This equals 0. So this equation is basically a cubic equation, and we are going to use synthetic division to solve this equation, that is to solve for n. So I'm going to put the coefficients like this. The coefficient of n cube is 1. So I put 1 first, and then the coefficient of n squared is negative 3. So I put negative 3, and then the coefficient of n is 2, and finally the constant term, that is negative 720. So we are using this synthetic division. Now we can try out some random numbers. Since this factor is a little bit huge, I'm going to try with positive 10. So I put positive 10 here, and I have to drop this 1 over here, and then multiply this 10 with 1. That is 10 times of 1 is 10. I put this 10 over here. Now we have to add these two, that is 10 minus 3 is positive 7. Once again we have to multiply this 10 with this 7. So 10 times of 7 is 70. We put this over here, and once again we add, that is 70 plus 2 is 72. And once again we have to multiply 72 times of 10, which gives positive 720. So we can add these two, and we get 0. So basically in synthetic division, we have to ensure that after we try out with one of the number, the last sum has to be 0. This has to be 0. So once we get 0, we can say that this is one of the factor of the given equation. So we say that n equal to 10 solves this equation. That is, if you plug in n equal to 10, it will the equation will satisfy and both sides will be true. And so this is the only possible value of n for this equation, because the other part, that is the remaining parts, if we write this as equation, we will write this as n squared plus 7n plus 72 equals 0. This is a quadratic equation, but this does not have a real solution. This does not have real solution. So we can ignore the other roots and we consider one of the roots of this cubic equation as n equal to 10. And this means we have determined the sides of the polygon. So therefore we see that the sides of the polygon is 10. It's a 10-sided polygon. We now determine the measure of each interior angle of this 10-sided polygon. We know that the measure of each exterior angle is given by 360 over n. So I'm going to first determine the measure of each exterior angle, that is exterior angle, and this equals 360 over 10. So we divide the 360 by 10, we get 36. So 36 degree is the measure of each exterior angle. And this means we can now calculate the measure of each interior angle, which is always 180 minus measure of each exterior angle. And so here it is 36 degree. So 180 minus 36 degree, and this equals 144 degree. So the measure of each interior angle of this 10-sided polygon is 144 degree.